Hello student, welcome back to lecture series on statistics. In my today's video guys, I'm gonna explain to you all one of the question which is based on the momentous chapter. Okay, now see that guys, this is the quite a descriptive type of question. Okay, so I'm gonna explain to you all first of all the question, then we apply formula. It is way easier guys. This is the example. It is very much important, ask plenty of the time in your university question paper. So maybe this time, maybe this one is important, or maybe you will get the some value replaced over here. Okay, so it is way easier to solve this example. Okay, so let's get dive into our today's lecture. I'm gonna explain to you all the detailed solution here. So if you're interested to see similar videos guys, go and check here in I button, or as well you will get entire playlist in my description box. Okay, yes, so let's get dive into our today's lecture. Here I'm gonna explain this example. Okay, now see that, let me read the question. The first four momentous of a distribution about the values 5 are, okay, so total number of values we have given 5. Okay, so we want the first four momentous. Okay, first four momentous. Let me read the question first. Okay, then you can understand it easily. Okay, the first four momentous of the distribution about the values 5 are 2, 20, 40, 50. Okay, yes, we have these many values given. From the given information obtained, first four central moment. Okay, first four central momentous. Then thereafter we want the mean, thereafter we want the standard deviation and the coefficient of the skewness and kurtosis. Okay, that means we want the coefficient of a skewness, coefficient of a kurtosis. Now see guys, I took one example where all concept involved here. Okay, first we want the given central movement. That means we want the information about the central momentous. It is given. We want the raw momentous, first question. Second question, we want the mean. Third question, we want the standard deviation, and the last one is a coefficient of a skewness, and the last one is a coefficient of a kurtosis. Okay, now see that one example, it covers all the topics. That's why I consider this example. Okay, so it is way easier guys, not that difficult. Okay, before I start this solution, you just need to understand momentous contain two types. Okay, momentous contain two types. First is a central momentous. Okay, first one is a central momentous. Okay, central momentous. This one is the first point, and the second is a second one, we have raw momentous. Okay, the second one is a raw momentous. Now see that what we have given. Okay, so we have given first four central moment. Okay, that means from the given information obtained first four central momentous. Okay, so that means we have to find out the central momentous. This one we have our target to find. We are finding the central momentous, and given we have here raw momentous. Okay, yes, and always remember that guys, raw momentous we denote mu dash. Okay, and central moment we denote mu. Okay, so you can consider anything. Okay, so we have given raw momentous. How many raw momentous are given? 1, 2, 3 and 4. Okay, these are the four raw momentous given. Okay, that means these are the given raw momentous. I hope you all have understood the difference between central momentous and raw momentous. Okay, so actually we have given raw momentous here. Okay, so first raw momentous, second raw momentous, third raw momentous, fourth raw momentous. Okay, and from the given this raw momentous, what we have to find? From the given information obtained first four central momentous. That means we have to find out the four central momentous, and we have given here mu1. Okay, raw momentous given means what we have given mu1 dash. Okay, raw momentous denoted as a mu dash, and central momentous denoted as a mu. Okay, yes, so raw momentous denoted as a mu dash. So mu1 dash we have 2 here, mu2 dash we have here 20. Okay, mu3 dash we have given 40, and mu4 dash given 50. Okay, so see that first, second, third and fourth, total number of 4 raw momentous are given. Okay, so this is the all value that we have given here. Okay, and now what we have given? First four momentous of the distribution about the value 5. Okay, so we have given first four distribution about the value 5. That means it's some sort of mean like structure. Okay, that means we have the value A, this one is the value A. Okay, so we consider A as a 5. Why I consider A? Because it sounds like the mean of a value of a mean. Okay, that's why I consider A as a 5. Okay, so mu1 dash, mu2 dash, mu3 dash and mu4 dash, these 4 values are here. Okay, raw momentous. Again we have given A5. Okay, I will explain to you all with the formula, guys, then it is easier to solve the question further. Okay, yes, well, let me explain what we have given first. Okay, this is the concept we have given in our question. Okay, and what we have to find from the given information obtained first 4 central momentous, and we know that mu can be denoted, we denote mu as a central momentous. Okay, and we want the first 4 momentous, that means we want the mu1. Okay, we want the mu2, we want the mu3 and we want the mu4. Okay, we want these 4 values, guys. Okay, that means we have to find out the first 4 central momentous, means we have to find out the mean mu1, mu2, mu3 and mu4. Okay, yes. So we know that the relationship between mu r and mu r dash, okay, that we have to apply over here, because these things are given, and if you want this one, that means you need to know the relation between these. Okay, so or instead of that, if you have given central momentous and if you want the raw momentous, for that you need to have an relationship between central momentous and raw momentous. Okay, so I do have here relationship between these two terms. Okay, see guys, these terms are very much important for your reference. You can check these ones. I explained everything in my last lecture. Okay, so if you want, you can check them out. Okay, yes. So we want the relationship between mu r dash and mu r. Okay, that means these are the mu r dash, total mu r dash here, that means it is the raw momentous. Okay, and mu1, mu2, mu3, mu4, mu0, these are the central momentous. Okay, these completely we have central momentous, and this one is the raw momentous. And what we want first central momentous. Okay, first central four momentous means this one is the first, this one is the second, this one is third and this one is the fourth. Okay, that means you need to prepare these formulas, guys. Okay, this is like some sort of formulas that we are going to use for solving central and raw momentous. Okay, you need to prepare this formula, recite them, or you can take a note for you all. Okay, because these are useful for solving the examples. Okay, so make sure that make it perfect. Okay, I'm gonna use this 4 formula for solving this question. Okay, so already we have mu1 as a 0 first momentous. Okay, mu1 as a 0 as a first central momentous, so you don't need to find out the mu1. Okay, so we are going to find mu2 dash, mu3 dash and mu4 dash. Okay, let me find the first 4 central momentous. Okay, yes. So as we know so far, we don't need to find out the mu1. We consider mu1 as a 0. Okay, as it is given in our formulas. Okay, so mu1 is a 0, it is already there. You don't need to worry about the mu1. Okay, so we are going to find out the mu2. So what is the mu2 in our relationship between mu r dash and mu r? Okay, so mu2, we know that mu2 dash minus mu1 dash. Okay, mu1 dash bracket square. Okay, mu2 dash minus mu1 dash bracket square. So what is the value for mu2 dash? See that mu2 dash we have 20 here. Okay, so we have to select this value from this one. Okay, so mu2 dash is a 20, so 20 take it here. Okay, minus mu1 dash, what we have mu1 dash, it is a 2. Okay, bracket square. So see that mu1 dash I replace here, and mu2 dash it is here. Okay, find out their values. Okay, 20 minus 4, it is a 16. Okay, 20 minus 4 is a 16. Now see that I got the value for mu1, I got the value for mu2. Now see guys, how easy the concept it is. Okay, you just need to have the need to know that these results. Okay, these are very much important. Yes, so let's go for the mu3. Okay, I want the mu3 also now, so you got the mu2 also, which is a 16. Okay, this one is the 16, mu2 is a 16. We want the mu3 now here. Let me find out the mu3. So mu3 can be found by mu3 dash. Okay, mu3 can be found by mu3 dash minus 3 mu2 dash mu1 dash plus 2 times mu1 dash bracket cube. Okay, see that these values we needed here for finding the mu3. Okay, so these are the all raw momentous, guys. Okay, and that we have given here. Replace this value and mu3 find out as the central momentous. Okay, yes, let me find mu3 now. So what is the mu3 dash? We know that the mu3 dash, it is given 40. Okay, mu3 dash given as a 40. So 40 minus 3 times mu2 dash. Mu2 dash is a 20. Mu1 dash is a 2. Okay, 3 times mu2 dash mu1 dash. Okay, plus 2 times mu1 dash cube. Okay, mu1 dash cube. So that means 2 times 2 cube. Okay, I hope you all have understood how I have written these values. Okay, so mu3 dash it is here minus 3 times mu2 dash here, mu1 dash here, plus 2 times mu1 dash cube over here. Okay, yes. Okay, so you go for calculation. So 40 minus 23 the 62 the 120. 120 plus 4 8 2 cube means 8 plus 2, 8 into 2 16. Okay, so if you find out this value, so you will get the minus 64. Okay, as I've already found these values, guys, that's why I'm writing, but you can use your calci because calcis are allowed for your END-SEM exam, so you can take this one. Okay, so I got the mu3 as a minus 64. Okay, so we got the mu3 as a minus 64. So I got the mu3 here, which is a minus 64. Now it is time to find out the mu4. Okay, let's do it for the mu4, guys. It is way easier than other values. Okay, yes, just you need to you need to know the one formula. Okay, so mu4 can be found by mu4 dash minus 4 times mu3 dash mu1 dash, 4 times mu3 dash mu1 dash, plus 6 times mu2 dash mu1 dash bracket square minus 3 times mu1 dash to the power 4. Okay, so see that, guys, you need to remember this formula. This is needed for finding the central momentous, or if you have given raw momentous, you can replace the value, you will get the central momentous. Okay, it is way easier. Yes, so now see that you need to know all these values here. So mu4 can be found by mu4 dash. Okay, what is the mu4 dash? It is a 50. Put the value here, mu4 dash, it is a 50. Okay, yes, minus 4 times mu3 dash, it is a 40, multiplied by mu1 dash, it is a 2. Okay, plus 6 times mu2 dash, it is a 20. mu1 dash bracket square, mu1 dash bracket square means 2 times 2 bracket square minus 3 times mu1 dash to the power 4, that means 2 to the power 4. What actually I have done, guys, here I just replace the given mu1 dash, mu2 dash, mu3 dash and mu4 dash over here. Okay, and go for the calculations. Always remember that, guys, if you are confused to solve these such examples, apply BODMAS rule, BODMAS, BODMAS rule for such a calculation, bracket of division, multiplication, addition and subtraction. Okay, this is the way you have to apply. Yes, so go for the further calculation for these many terms, guys. Okay, so mu4, after finding all this calculation, we will get the 322 as a mu4. Okay, so I got the mu4 as a 322. Okay, so what is the value for mu4? 322. Okay, so I got the mu1, mu2, mu3 and mu4. Okay, all these 3 central momentous, 4 central momentous we want. Okay, what we have given, obtained first 4 central momentous. Okay, I got this first 4 central momentous. Okay, now next part of the answer, we want the first mean now. Okay, let's work for the mean. Okay, I'm finding the second part here. Okay, what is the second part? Mean. Second part, we want the mean, and the mean can be denoted as x bar. Okay, mean we denote it as the x bar. Yes, so we know that by using raw momentous we have to find out the x bar also. Okay, yes, so in my last lecture I explained to you all for finding raw momentous one formula. Okay, I explained in my last lecture. But if you still confused about this formula, guys, go and check in my video. You will get the complete detailed understanding of that formula. But still, for mean, I will explain the formula, and I'll try to create the formula that can use these many value, okay, the formula that can use these many value, and we will get the answer x bar. Okay, yes. So what formula we learn in our last lecture? Okay, in last lecture I explained this formula mu r dash. Okay, now see that as we have given raw momentus na, that means we have to attack the formula from here. Okay, so mu r dash, what is the mu r dash? We know that summation of fi xi minus a to the power r divided by capital N. Okay, this is the formula that we learned, guys, in our last lecture. Okay, yes. So what we want the mean. Okay, so for mean you can consider any value. Okay, so for that I'm going to consider mu1 dash, because now see that you have to consider whether mu1 dash, mu2 dash, mu3 dash or mu4 dash. Take any one of the value, okay, for this formula. So I'm going to replace r as a 1. Okay, so I'm going to write mu1 dash can be written as summation of fi xi minus a, okay, r keep as it is divided by capital N. Okay, so using all these values I'm going to find out the mean x bar. Now observe carefully how I am finding the value. Capital N, we know that capital N can be written as summation of fi. Okay, capital N means summation of fi. So make sure that summation of fi it is there. Okay, yes. So multiply summation of fi under bracket and divide summation of fi separately to the term. Okay, yes. So what I am going to do, I am going to multiply summation of fi to here and here as well. Okay, so summation of fi into xi minus summation of fi into minus a. Okay, summation of fi minus a, sorry, minus of summation of fi into a. Okay, this is the multiplication between these two value. Okay, and denominator we know that summation of fi is there, summation of fi, here it is also summation of fi. Okay, so this is actually I expanded this formula in this way. Okay, and I taken mu1 dash because we have given mu1 dash, so right hand side I can replace as directly value for mu1 dash, and another side can easily gives us the value. Okay, yes. Okay, let's go for next part. We know that summation of fi xi divided by summation of xi, it is the arithmetic mean. Okay, it is the arithmetic mean for the grouped data. Group data, arithmetic mean for group data, summation of fi xi divided by summation of fi. Okay, this is the arithmetic mean for the group data. So put that value over here, x bar. Okay, minus, so what we have here, a, it is a different term completely. Summation of fi cancel, it is here. Okay, because summation does not matter on the term a, so keep a as it is. Okay, so I got the mu1 dash which is equal to x bar minus a. I hope you have understood how I have written. Okay, so I derived one formula that can give us a mean. Okay, so we can find out the mean easily using this formula. Okay, yes. Okay, let's go for finding the value for x bar. We want the arithmetic mean, means we want the value for x bar. Okay, take these two terms to the one side. We write mu1 dash plus a which is equal to x bar. Okay, yes, we write x bar which is equal to mu1 dash plus a. Okay, we write x bar which is equal to mu1 dash plus a. Now see that we have given mu1 dash and we have given a. Now see here we have given mu1 dash is a 2 and a which is equal to 5. Okay, mu1 dash means it is the first element over here. Okay, and a means total distribution about the values, it is a, we consider this one as a. Okay, so a is a 5. So put here x bar which is equal to what we have here, mu1 dash is a 2 and a is a 5. 2 plus 5. Okay, we get the x bar as a 7. Okay, this one is our arithmetic mean. Okay, I hope guys you all have understood. It's not that difficult. This formula I explained in my last lecture, but using this formula to derive mean, I explained this quantity over here. Okay, so if you want you can take a note of this formula, that one is needed. Okay, yes. So I derived this formula using this one. I found out the value for x bar which is a mean over here. Okay, yes. So we have next destination which is needed, standard deviation. Okay, standard deviation, and then we go for the coefficient of skewness and kurtosis. Let's go for the third part for finding the standard deviation. So our next part is to find out the standard deviation, okay, using our given data. Guys, note it down one remark which is more important here for us, okay. So standard deviation can be found by square root of variance, okay, and mu2 can be written as variance also. Okay, mu2 can be written as variance also, okay. So if you don't know, then take the note of this mu2, it is also written as variance, okay. So see that what is the value for mu2 we got it here, it is a 16, okay. So this is the actually value for variance, okay. So we got the variance as a 16 over here, okay. This one is a 16. So I got the variance as a 16, and we know that the standard deviation sigma can be written as square root of variance. Square root of variance can be written as the standard deviation also, okay, or standard deviation which is equal to square root of variance. So we want the standard deviation, that means square root of 16, okay, which is a 4. So I got the sigma which is equal to 4 over here, okay. Yes, this one is a sigma as a 4, okay. I got the value for standard deviation. Now see that we want the next target here, okay. So we have next target. I hope you all have understood standard deviation. If you don't know the mu2 as a variance, then take the note of this, okay. And standard deviation can be written as square root of variance. These are the most important concept here, okay. Yes, after the standard deviation we want the coefficient of skewness and coefficient of kurtosis, okay. Let me find out the coefficient of skewness first, okay. So we have fourth question. What is the fourth question? We need the value for coefficient, okay. Coefficient of skewness, okay. We want the value for coefficient of skewness. Yes. Now for the coefficient of skewness, we know that we denoted it as the beta 1, okay. Coefficient of skewness, we denote this one as the beta 1, okay. So coefficient of skewness means that actually to get the idea about the shape of a curve, okay, or to get idea about the given data sets, okay. So this one we consider the coefficient of skewness. So we already learned the different measure of skewness and the coefficient of skewness. So we need to know one standard formula for finding the coefficient of skewness. And coefficient of skewness, okay, coefficient of skewness can be found, okay. So we write it as the beta 1, okay. Coefficient of skewness we write as the beta 1, okay. And beta 1 we know that we write this one as the mu3 square upon mu2 cube, okay. Using mu3 square and mu2 cube we can easily define the value for coefficient of skewness, okay. So we know that the mu3 and mu2, okay, that we found here, mu2 is a 16 and mu3 is a minus 64, okay. Put these values here, mu3 which is equal to minus 64 bracket square upon mu2 which is equal to 16 bracket cube, okay. Yes, so if you want you can use the calci, guys, okay. It is way easier for finding the calculation. We know that minus 64 square and 16 cube both gives us the value equal, so it is coming as 1 over here, okay. Yes, so 16 cube means take 16 multiplied by 16 multiplied by 16, okay. So coefficient of skewness that we consider designated as a beta 1, and this when having value 1, okay. So we know that the beta 1 is a 1, okay. Yes. Now next concept, next what we want here, so that we can say that, okay, the distribution is a positively skewed. As we have beta 1 is a 1, then we write the distribution is positively skewed. Okay, the distribution is a positively skewed, as we have beta 1 as a coefficient of a skewness. Okay, yes, we got the coefficient of a skewness. Now what we have next target, we want the coefficient of a kurtosis. Okay, coefficient of a kurtosis, and which we denoted as the beta 2. Okay, our fifth target is here to find out the coefficient of kurtosis. We want the coefficient of kurtosis. Okay, and the coefficient of kurtosis, we denoted it as the beta 2. Okay, we denoted coefficient of kurtosis as the beta 2. Okay, yes, in my last lecture I explained, guys, you all the coefficient of kurtosis here, beta 2. So if you want, you can check it here. This is the concept I explained in my last lecture. Okay, so that one we needed here. So actually we have three types of the kurtosis. First one is a mesokurtosis, second plateaukurtosis, and third leptokurtosis. Okay, so if beta 2 got the value 3, then it is a mesokurtosis. If beta 2 is smaller than 3, we write it as a plateaukurtosis, and if beta 2 it is bigger than 3, then we write the leptokurtosis. Okay, so we are going to apply these three values for beta in order to define whether kurtosis is a mesokurtosis, plateaukurtosis, or leptokurtosis. Okay, and for measure of a coefficient of a kurtosis, we use a mu4 upon mu2 bracket square. Okay, yes, we have mu4 upon mu2, we know the value, just replace the value in formula, we'll get the answer. So here I have written the formula for coefficient of kurtosis, which is a beta 2 which is equal to mu4 upon mu2 square. Okay, so replace the value for mu4 and mu2 square. Okay, so what is the value for mu4? 322, and mu2 square means 16 square. Okay, that means 322 divided by 16 bracket square. Okay, 322 divided by 16 bracket square. So if you are going to divide this one, we will get the 1.26 answer. Okay, yes, so beta 2, we got the beta 2 which is equal to 1.26. Okay, now we have to decide the whether it is a plateaukurtosis, mesokurtosis, or leptokurtosis. Okay, which one of the type is there. Okay, so I already explained you all, guys. If the beta 2 smaller than 3, plateaukurtosis, beta 2 exactly 3, mesokurtosis, and beta 2 bigger than 3, it is a leptokurtosis. So we got the beta 2 as a 1.23. Okay, we got the beta 2 as a 1.26. Obviously it is smaller than 3. If a beta 2 smaller than 3, then we write the plateaukurtosis. Okay, if beta 2 smaller than 3. Okay, if a beta 2 is the smaller than 3, then we write it as the plateaukurtosis. Okay, then it gives plateaukurtosis. Okay, now see that 1.26, it is obviously smaller than 3. Okay, so beta 2 is in our given example, beta 2 is the plateaukurtosis. I hope, guys, you all have understood. We have total 5 number of the question in one question, sub questions in one question itself. Okay, I hope you all have understood everything. So for your note, you can note it down, this example, very important, guys. You will get the similar type of question in your question paper. So if you want, note it down, this example. So here first question, then we found here central and raw momentous relationship. Then after that you can refer for mean over here. After mean, standard deviation I found here. And then coefficient of a skewness denoted by beta 1, coefficient of kurtosis beta 2, and we found that it is the plateaukurtosis. Okay, I hope, guys, you all have understood everything here in my today's lecture. Okay, so even after, guys, if you have anything doubt, difficulty, let me know in my comment section. Okay, I don't think so it is anything difficult over here. You just need to have a concept only. Okay, prepare this example for your END-SEM examination. This one is very important. Okay, I hope everyone, you all have understood everything here in my today's lecture. Even after, if you found anything difficult, guys, let me know in my comment section. Okay, that one will be my motivation for uploading more videos. So thank you everyone, thank you for my today's lecture.